Hello everybody! In this video we will quickly discuss two applications of electrolysis. First, let's discuss the electrolysis of water.
As you have previously learned before, water naturally self-ionizes, meaning that water dissociates into hydronium, or also known as H3O+, and hydroxide, or also known as OH-. However, very few of these ions are normally present in pure water. The concentration of these ions can be increased using a process known as electrolysis.
Electrolysis of water is the oxidation-reduction reaction, or redox reaction, that occurs when a voltage is applied to the water. The process of electrolysis of water is actually quite simple.
As mentioned before, water separates into hydronium and hydroxide ions. When a voltage is passed through an electrolytic solution of water, electrons are supplied to the hydrogen ions at the cathode, causing reduction to occur and generating hydrogen gas. Meanwhile, at the anode, the hydroxide ions are deprived of electrons, causing oxidation to occur, while generating oxygen gas and water.
Another application of electrolysis is seen in the production of sodium. Since sodium is very reactive, producing it through a chemical process is extremely dangerous, which is why electrolysis is used instead of a chemical process to produce sodium.
As previously mentioned, sodium is extremely reactive and gives away electrons extremely easily, which makes it a very good anode in electrolysis. The production of sodium is accomplished by the electrolysis of molten sodium chloride.
The first step in the process to obtain sodium is to mix sodium chloride, a common and cheap compound otherwise known as table salt, with solid calcium chloride to reduce sodium chloride's melting point from 800 degrees Celsius to 600 degrees Celsius. Lowering the melting point of the substance reduces the electricity needed to carry out the electrolysis, which is cheaper and better for the environment. Woohoo! The mixture is then introduced into an electrolytic cell called a down cell. In a down cell, a circular iron cathode surrounds the carbon anode. The products of electrolysis are separated by steel mesh or gauze to prevent them from coming into contact and reforming the sodium chloride, which would render the entire process useless. Finally, if done correctly, sodium can be retrieved as the product. Are there any questions?